Do it. Goodbye. So a 3,800 square feet commercial building features a long span timber roof system that is supported by reinforced concrete masonry shear bearing walls. Design references: IBC International Building Codes for the ASCE 7, minimum design loads and associated criteria for building and other structures. Seismic design parameters: the SDS is 0.7, the SD1 is 0.25, the S1 is less than 0.75. So using the equivalent lateral force procedure, determine the seismic base shear, assuming W is the total seismic weight of the structure. So the base shear is most nearly what? So if we read, so by reading this problem statement, so again with the same mindset, the final step we gotta find what the seismic base shear is, but we're not given the weight, right? So we can express the seismic base shear in terms of the weight. We know per equation 12.8.1 of ASCE 7 that the seismic shear is equal to a CS times a W, the weight. So here we're not given the weight, but we can express it in terms of, we can express the seismic shear in terms of the weight, like I said. So it's a matter of finding what the CS is. Just inspecting this problem, we're not given the long period transition period. So we don't know we're not supposed to be concerned with the fundamental period. So we're just going to be looking at the basic equation, the 12.8.2, that tells us that the CS, right, is equal to an to an SDS divided by an R, right, the response modification factor divided by the importance factor. Okay. So we know the SDS is given. It's given to us as 0.7. To find the R, we got to go to table 12.2.1, and to determine the R, we need to find out basically what the seismic design category is. So you just gotta have to have worked this problem to know how to solve it. So you gotta go to table 11.6.1. Okay, table 11.6.1, and it tells you depending on the risk category of the building. So we have a commercial building, so it's a risk category 2. So depending on the risk category, you can find what the seismic design category is by knowing comparing the SDS value. And if the SDS value is greater or equal to 0.5, regardless of what the risk category is, so the seismic design category is D. All right, so in this case, our SDS is 0.7, obviously greater than 0.5, and it's a risk category 2. So right up the bat, we know that the seismic, right, design category is a D. Okay, so it's a D. It's a D. Since it's a D, we have to use a special reinforced concrete masonry bearing shear walls here. And if you go to that table 12.2.1, it's a matter of just reading what the R is, right? So you got to search for special, since we have a seismic design category D here. And the response modification factor would be 5. So you got to go to that table to find that out. All right, so it's a 5. Importance factor. So importance factor, we got to go to for importance factor, chapter 1. Chapter 1, 1.5. So 1.5.1 would give you what the risk categories are. If you go below that, so there's a table that gives you what the importance factor, and that importance factor here would just depend on the risk category of the structure. Risk category, we already know that it's 2. So for seismic base shear, the importance factor would be 1. So the IE here is 1.0. Okay. So now we have everything to find what the CS is. All right. The CS would be, so grab a calculator here. The SDS is 0.7. Okay. 0.7. That we multiply by 1, okay, and we're dividing by 5. Okay, so it's 0.14. Okay, So our shear V would just be expressed in terms of the weight of the structure. So you got to find what the total weight of the structure is, and say that the seismic base shear is just equal to 0.14 times the total weight. All right, and that's the answer. Pretty straightforward. Pretty straightforward. Let's do it. Goodbye.